Welcome you all. In this session, we are going to discuss HVDC transmission. Outcome: after successful completion of this session, the student would able to explain the operation of HVDC transmission. Electric power transmission was originally developed with DC. The availability of transformers and the development and improvement of induction motors at the beginning of 20th century leads to the use of AC transmission. DC transmission now became practical when long distance were to be covered or where cables were required. Thyristors are applied to DC transmission and solid state valves became a reality. DC transmission now became practical when long distance were to be covered or cables were required. So now, with the fast development of converters, both rectifier and inverters at higher voltages and larger current, DC transmission has become a major factor in planning of power transmission. In the beginning, all HVDC schemes used mercury arc valves in construction. So later, due to the improvement or development of SCR and thyristors, it has been switched to power converters. In large interconnected systems, power flow in AC ties, that is connecting to AC system, can be uncontrolled and lead to overloads and stability problem. Thus the system security may get damaged. The strategically placed DC lines can overcome this problem due to the fast controllability of DC power and provide much needed damping and time overload capability. The planning of DC transmission in such applications requires detailed study and evaluate the benefits. Example is Chandrapur plug link in India. This is the best example for HVDC transmission. Presently, number of DC lines in the power grid is very small compared to the number of AC lines. This indicates that DC transmission is justified only for specific applications. Although advances in technologies and introduction of multi-terminal MTDC systems are expected to increase the scope and application of DC transmission, it is not anticipated that AC grid will be replaced by DC power grid in future. Need for HVDC system. For long distance bulk power transmission, HVDC system may be less expensive and suffer a lower electrical losses. For underwater power cables, HVDC avoids heavy current required to charge and discharge the cable capacitance each cycle. For shorter distance, higher cost for DC conversion equipments compared to AC may still warranted due to the other benefits of DC current links. HVDC allows power transmission between unsynchronized AC transmission systems. Since the power flow through a HVDC link can be controlled independently of phase angle between the source and load, it can stabilize a network against disturbance due to rapid changes in power. HVDC also allows transfer of power between grid systems running at different frequencies such as 50 Hz and 60 Hz. This improves the stability and economic of each grid by allowing exchange of power between the networks. HVDC allows power transmission between unsynchronized AC transmission system. Since the power flow through a HVDC link can be controlled independently of phase angle between source and load, it can stabilize the network against disturbance due to rapid changes in power. HVDC also allows transfer of power between grid systems running at different frequencies such as 50 Hz and 60 Hz. This improves the stability and economy of each grid by allowing exchange of power between the incompatible networks.